So our last lesson of the year is inverse trig in radians. So this lesson will look very familiar. The only thing that's changing is from degrees to radians. So we're still going to be evaluating trig functions, but this time in radians. And we're also going to solve trig equations in radians. So evaluating trig functions, again, taking a look at the unit circle, remembering the restricted domain for each of our functions. So for sine inverse, our restricted domain is from negative pi over 2 up to positive pi over 2. So those will be the only values that we will give for an answer for our sine inverse function. Square root of 2 over 2 is in the positive first quadrant, and that is 45 degrees, or in radians, pi over 4. Tangent inverse has the same restricted domain, the negative pi over 2 to pi over 2, and the negative means we're in the fourth quadrant, and square root of 3 over 3 is negative pi over 6. And finally, cosine inverse of 1, again here, is where we have the ordered pair 1, 0, so this would be 0 radians. So now we're going to take a look at giving the general solution for each trig equation in radians. So what we need to talk about first is what the period of the tangent function is in radians. And we talked about how on the last video, the tangent function goes from positive to negative to negative. So it has a period of half a rotation, 180 degrees, or in radians, pi radians. So that will be the value that we add after we solve our equation. So we take the tangent inverse of both sides, and we think about that restricted domain, where is the tangent function equal to the square root of 3, and in radians, it's at pi over 3, plus pi n this time, to keep our units in radians. For cosine, we're going to divide both sides by 6. Simplifying, we get negative 1/2. Remembering the restricted domain for the cosine function is from 0 to pi in radians. When we find the cosine inverse of negative 1/2, we are in the second quadrant, and the cosine is 1/2 at 2 pi over 3. Sorry, so I took the cosine inverse of both sides. The period for the cosine function, because as we talked about on the last video, there's no repeating pattern, it's positive, negative, negative, positive, it's a full rotation, or 2 pi n. And again, as I mentioned, there is actually another answer that you will probably take a look at in pre-calc, but we're just going to do the basics for now. Same with sine. There are two answers when you take the sine inverse and you want the general solution, but we're just going to take a look at the first one. So dividing both sides by negative 2. Remembering our restricted domain for the sine is negative pi over 2 to positive pi over 2. So thinking about where the sine function is negative square root of 3 over 2, and that occurs, I get the same answer for all of these, that occurs at pi over 3. So taking the sine inverse of both sides, and sorry, it's negative, so it's negative pi over 3. We're in the fourth quadrant. And same thing for the sine function, there's no repeating pattern. Sine is positive, positive, negative, negative, so it doesn't repeat until you make a full rotation, or 2 pi radians.